Okay, so dear students, now I'm going to talk about the solution for the multi-fragment heuristic, question number 1 in your sample question bank for the final. So you're given this edge weight matrix and you want to find an approximate tour for this, for the traveling salesman problem. So the first thing you have to do is sort the edge weights. So I have sorted them out. So then you really start seeing what are the vertices you can have. So A to E is it is possible. That's the minimum edge weight. So you are going to consider the edges in the increasing order of the edge weights, right? Okay, so A to E is an edge. Now D to F. Let me pull it a little bit. D to F. Yes, you could have that as an edge. A to D, you could have that as an edge. E to F. Now if you add that edge from E to F, it's going to create a kind of a subtour. We want every node to have only two edges connected to it, and the two should start with one vertex, go around and come back to that starting vertex. So here we can't have a subtour like this and then go up the other vertices. Okay, so each vertex should have exactly two edges connected to them. So just remove this. Then B to C, yes, you can have something from B to C. Now you cannot have from A to C this because it's going to create a kind of three edges are attached to A, so you cannot do that. B to E is going to be something like this. That's possible. Then C to E, we cannot create that one. The reason is it's going to create a subtour. Then A to B, we cannot do that. If you do, it will end up being something like this, right? Then C to F, yes, it is possible to have from C to F something like this that completes the tour. So now let's come up with the edge weights. So this is 1. D to F is also 1. And A to D is 1. E to F is not there. B to C is, sorry, A to D is 2. I'm sorry. B to C is 3. Then A to C is not there. B to E is going to be 4. C to E is going to be not there. A to B is not there. C to F is going to be 5. So the weight of the current tour is going to be the sum of all these edge weights, which is 6, 8, 12, 16. Okay, so the weight of the tour is going to be 16. Now we'll see whether we can reduce it further using the two-change heuristic. So for that, you have to first pick two edges. So the way we'll pick the two edges are, the first edge we'll pick is the edge with the maximum weight, which is this 5. Okay, so this will be the edge that we'll pick as one of the edges. Then the adjacent edges cannot be picked as a candidate. So the next candidate that they can choose is this edge of weight 4. Right? So basically now we have a tour coming from here and then this edge and then this going around this edge. So the only way we can really remove these two edges and kind of kind of get it reorganized is going to be, you cannot do like this, right? Because it's going to disconnect. So we have to do something like this and something like this. So the weights are going to be E to C to E is 4, and F to B is going to be 7, right? So the total weight is going to be increasing by, you removed 4 and 9, and this is going to be 11, so it's going to only increase by 2 units, so 18. If you add all of them, 4, 8, 11, 15, 18. So it's not going to decrease the weight of the tool. We want the weight of the tool to be decreased, so which means this is not a feasible solution. So we cannot really do. You can try something else too. I don't think that will be possible. You can try. Right, so for this problem, you cannot optimize this further. You cannot optimize further. Or we can show the work. Actually, better show the work. So it is increasing. It is only increasing to change heuristic applied on this tool only increases the weight of the tool, hence we cannot do to change heuristic. The weight of the tool is 16. Has to remain at 16, right? Okay. All right, let me save this and stop this. Now, before I stop, let's go to the nodes. I have there an example where the weight of the tool could be reduced further. If you remember what we see in what we saw in class, this example where again I sort the edge weights. Okay, so I started V2, V6, then V1, V3, then V2, V5 is there, V1, V6 is possible, V2, V4 is not possible because that's going to create, V2 already have V5 and as V5 and V6, so if you connect V2 and V4, V2 is going to have 3 edges attached to it, so we cannot add that edge to V2. Similarly, V1 to V2, we cannot do that because that's going to create a subtool. V2 to V3, that's going to also create a 3 edges attached to V2. Then V3 to V4, it's going to be possible. Then V4 to V6, it's not possible because that's going to create a subtool. Then V1 to V5, it's going to create a subtool. V3 to V1 to V5, not possible. V3 to V5, not possible because that's going to create 3 edges connected to V3. Then V3 to V6, going to create a subtool. Then V1 to V4. That's not possible too, going to create a subtool. So the only thing we can do is V4 to V5, so which is what we connect to. Okay. Let me do if that's not clear. Let me just say these are V2, V6, V4. Alright, let's do it one by one. So you have V2 to V6, so let me create an edge. Then V1 to V3, that is fine. then V2 to V5, that is fine too. So I can create an edge. Then V1 to V6, is it possible? Yep, I can do it like this. V2 to V4, we cannot do that. Why? Because that's going to create 3 edges connected to V2, so we cannot do that. V1 to V2, that's going to create a subtour, so V4 has to be here. Now we cannot do this from V1 to V2. V2 to V3, we cannot do that because that's going to again create 3 edges to V2. Like if you do it like this, it's going to create 3 edges to V2. V3 to V4, that's possible. It's going to create something like this. What I can do is I can rearrange this little bit. Let me do that so that it becomes easy to visualize. And let's see. So you can really connect now V3 to V4. And then V4 to V6, we cannot do that because that's going to create a subtour. V1 to V5, we cannot do that because it's going to create 3 edges to V1. V3 to V5 is going to create 3 edges to V3. V5 to V6, subtour. V3 to V6, subtour. V1 to V4 is going to get a subtour. So only thing left over is V4 to V5, which is this. So now this is a tour, which is what we have there. Now if you put the edge weights, this is going to be 9. V3 to V4 is going to be 5. V2 to V5 is going to be 3. V2 to V6 is going to be 2. V1 to V6 is going to be 4. And V1 to V3 is going to be 3. So the total weight is going to be 14 plus 17, 19, 23 and 26. Okay, so the weight of the tour is 26. So now if you want to see if you can use two-chain heuristic to reduce this weight further, the way you will do that is you will pick the largest edge weight. So once you pick this, you cannot choose the two adjacent edges, this edge 5 and this edge 3. You cannot choose that, so you have to choose among the other remaining 3 edges, 2, 4 and 3. So we'll target the largest edge weight, which is this 4. Okay, so that is going to be our target. And so basically we have to see if we can really connect V5 with V6, remove these two, and if you connect you cannot connect V5 and V6 because that's going to create a subtour, right? So only way you can do this is connect V5 to V1, because if I connect to V6 it's going to create a subtour, right? so you cannot do this. So what you have to do is you have to connect to V1 and connect V4 and V6. So that's going to create a tour. You can start from here, go to V1, go to V3, V4, V6, V2 and V5. So V1 to V5 is going to have edge weight is going to be 6, and V4 to V6 is going to be 5. So the total edge weight is going to be 11. The total sum of the two edges that you added is 11, and the previous one, 9 plus 5, is 14. So you remove two edges of total weight 14, 9 plus 5, and added two edges of total weight 6 plus 5, which is 11. Right? So which means you have reduced the weight by 3 units, right? So the new weight of the tour is going to be 23, which is, like, you can verify, 6 plus 3, 9, 11, 14, 22. Is it 22? Should have been 24, right? Let's see. Did I miss anything? V5 to V2, V2 to V6, V6 to V1, V1 to V3, V3 to V5. This is now we added V5 to V1, that is 6. V4 to V6 is 5, so it is like 9 plus 11, 16, 21, 24. Right, I did the math wrong. Okay, good. Okay. Six plus 3, 9, 11, 16, 21, 24. Good. All right. So the weight of the tour reduced by 2 units. Right. Let's stop.